Linear equations of one variable. Let's think about what that means. If something is linear, perhaps you think of a line, a straight line. I think of a variable raised to the first power. So something like x or y, not x squared. The word equation in mathematics, well, it's just saying that there's an equal sign. Unlike an expression where there was no equal sign, this now has an equal sign. And we only have one variable. So I only have an x. I wouldn't have, say, an x and a y. I might have y by itself. The variable name can change. However, I'm only going to have one. So, for example, these types of equations, let's just look at what they appear like. An example of this concept is something like, say, x is equal to 5.7. A very simple linear equation of one variable. The variable is x. It's an equation because it has an equal sign, and we know that it's telling me that there's one value for x that will make this equation true, and that's 5.7. That's pretty obvious. Another linear equation of one variable is 3 minus x is equal to 1. X is to the first power. There's an equal sign, and there's some numbers. Okay, one more example, something like 5x. I could say, let's change it to y. 5y minus 2 equals, say, 3.25. That's a linear equation of one variable. It's an equation because I have an equal sign. There's one variable, just namely y, and it's raised to the first power. Now we don't usually write the 1, but it's there. So what does it mean to solve one of these? So we're going to solve this equation. Solve is a little different than simplify. Often we'll say solve and simplify. But the word solve itself, if I ask you to solve something, first of all, it has to do with an equation. You know you have an equation if we're solving something. So in other words, solve something, it better have an equal sign in it. And solve has a specific meaning. It means find the value. So an actual number, the value or number for the variable, the one variable we've been talking about, that makes the equation true. Now we've done some examples of this where we've said, here's an equation when x is equal to 3. Is that a true statement? Is that equation valid for that particular value of x? Well, now we're not going to know x, we're actually going to find it. The general form of a linear equation of one variable looks like this. A, and I'll use x as my variable, plus b is equal to c. In this case, we have a, b, and c are real numbers. It means they could be decimal, they could be rational, they could be negative. So let's look at those examples I gave you before. X is equal to 5.7. And let's write down what a, b, and c are. So I'm going to compare the form of this equation with the one I'm looking at. So what's in front of the x? I just have x equals, so there must be 1 times x. So that means the number in front of x is a, so a in this case is 1. I'm not adding anything to x, so b must be 0. I've added 0 to x. And c is what comes after the equal sign, in this case 5.7. 3 minus x equals 1. In this case, it might be easier to rewrite this and commute the minus x and the plus 3. So we could write this as minus x plus 3 equals 1. Right? Because really there's a plus in between here. 3 plus this negative x. And we know that addition is commutative. So in this case, what's in front of the x? Well, negative x is the same as saying minus 1 times x, so a would be negative 1. Looking at our equation again above, in general form, I'm adding 3, so b is 3, and c would be 1. In the last example, I think it was something like 3y or 5y, perhaps it was. Let me go and correct that. I think it was 5y. Just testing short-term memory. Minus 2 equals 3.5. Perhaps it was something like that. Now with the variables y, a is what's in front of the variable. Even though in the general form we use x, it's just really just denoting that there's a variable there. So in this equation, the variable is y. What's in front of the y? The a is 5. Now what am I adding? I'm going to plus b, but again, we've practiced this. This is actually plus a negative 2. So in this case, b is negative 2, and c is 3.25. So let's try this. Let's try to solve the equation x plus 5.2 is equal to 2.7. We can think of the equal sign as sort of a fulcrum. If I had a scale, and on that scale I put little plates, right? Like a weighing scale, right? And I could put things on these scales, and if they were the same weight on the left and the right, then the bar across the top would be nicely even right down the middle. Right? They'd weigh the same on either side. I should make them look a little bit more similar, but that's the best I can do. So we're thinking of this like a weighing scale. This equals. So what's on the left has to equal what's on the right. What I can do to this equation now, let me rewrite it. X plus 5.2 is equal to 2.7. On the next line, I'm going to subtract 5.2 from this side, from the left. When I do that, notice I have a plus 5.2 and a minus 5.2, so they add up to 0. These are the like terms I'm adding, so I'm left on the left-hand side with just x. But if I were to actually put something on this scale, I had, say, 5.2 sitting here on the scale, and if I take it off, right, if I subtract it, what's going to happen? Well, the scale is just going to drop on this side. So I have to remove the same amount from the right-hand side. So I'm going to subtract 5.2 from the right-hand side. And I get, in this case, 5 is larger than 2, right? So it's going to be negative. I'll drop the equals down in line with the one above it, and I get x is equal to negative 2.5. All right, we say that this equation, x equals minus 2.5, is equivalent to our starting equation. Or my solution to the equation is x equals, or it's true, when x is equal to minus 2.5. So let's check that. How would I check that? I go back to the original equation, x plus 5.2. This is going to be pretty simple, 2.7. I plug in my value that I found into x, 2.5, and I add that to 5.2, and I say, big question mark here, does that equal 2.7? We add this together and we say, yes, in fact, this is true. Because I get equal values on either side, then I know that my equation has been solved. Here's a problem that's a little more difficult. I have x on both sides. It's rather difficult to say which one's a and which one's b and which one's c because I'm not in that general form. So I'm going to, in essence, move the variables to the left and the numbers to the right, and I'm going to do that using this idea of addition. So I don't want a minus 4x on the right hand side. So I have a minus 4x. If I added plus 4x, I hope you can see that when I added these two I'd get 0, so the only thing left on this right hand side would be 9. I'd still have to add the plus 4x on the other side, otherwise I've changed the equality. But these are like terms. When I add them I get x minus 5. Well, this is in the general form now. A is 1, b is minus 5, c is 9. Now I can add 5 to both sides of the equation. When I add 5 on the left hand side I just get x because minus 5 and plus 5 equals 0, and here I add 9 and 5 and 14. So my answer now is x equals x equals plus 14, and we could check this as we did before. So it's a good idea, if you get an equation that's not in general form, to put the variables on the left hand side, the numbers on the right hand side, and we do this by the addition method.